So let's talk about the key concepts and define them properly, so we all have a shared understanding. First and foremost, we have the augmentation. That's the digital representation of the data that we need to send to effectors, so the effector outputs that then serve to stimulate the sensory experience of the user. That includes output modalities such as visual, audio, haptic, but there are many more that we can actually serve. For example, electrostimulation of the tongue to augment taste. Um, we then can refer to the archetypes of such augmentations as augmentation primitives. They define the types of annotation available in an augmented reality system. Typically, this includes, but again, it's not limited to audio, video, images, animations, labels, and vibrotactile patterns, but there can be many more. There are many different types of delivery systems available, and of course that applies also to the visual sense as the most advanced medium probably for augmented reality delivery. Amongst the delivery systems, we can distinguish, following the distinction from Bimber and Raskar in 2003, the following systems. We have, for example, retinal displays. That would be contact lenses. That's rather experimental technology at the moment, not really in the market. We have very popular head-mounted displays, smart glasses, but also head-mounted projectors that work the other way around, so they're outwards facing, they project in front of you, and similarly there are also handheld projectors that people work with, museum context, for example. Handheld displays are the iPad, mobile phone. We've all had a horrible experience technically with Pokemon. That's for sure. There are spatial see-through displays, such as you would find at a bus stop, for example. And there are then different types of projection systems, spatially aligned projectors, sometimes overlapping to increase the lumen count and have wider coverage. Sometimes with specifically prepared canvas, such as hologauze or pepper scrim, and they then deliver the actual visual augmented reality experience. They fall into these three types, that they're head attached, body attached or handheld, and then fixed installed spatial. Very popular, of course, these days, head-mounted device technologies. There are essentially 4 different types of device technologies that you would find currently in smart glasses. I've depicted them here. The ones that use a prism are, for example, a Google Glass that has a little cube in the glass that is used to reflect the light beams coming from a projector into your eye and combining them with the light beams coming from the real objects. That's relatively cheap and small technology. Bit more bulky typically are beam splitters, so that's the best example is probably one of those slot-in devices where you put your mobile phone in so that the display reflects into that semi-transparent beam splitter, the grating that is depicted there in front of your eyes, and there is a curved mirror that allows light beams to pass through unobstructed from the real world. Both pictures combine then to the augmented reality experience. Typically, these devices are quite bulky at the moment. That's why some people call them bird baths. Thank you, Vast 3K. There is also a waveguide technology that uses a projector again to send the light into kind of fiber optic similar material, which bends the light beam, reflects it into a system of mirrors so that they're let through exactly when they need to, combining them again with unobstructed light beams coming from the outside world. And that's the technology you would find, for example, in the HoloLens in various forms. And then technology you also find there, laser beam scanning, that's similar to the old CRT cathode ray displays. that we have all been pained with many moons ago. Similar insofar as a laser beam is rapidly moving and delivering the picture just like a very quickly interlaced picture to your eyes. Again, then combined with some semi-transparent material to let normal light beams pass through unobstructedly. This technology is cheap because it basically only needs glass to be coated with holographic film, and once that can be combined with better depth sensing technology, such as the waveguides you currently find in the market, that may actually be the future. Who knows? It's very difficult to predict, but there are certainly different horses in the race here. Tracking subsystem is another key component that you would find in an augmented reality system. The tracking subsystem utilizes sensors to detect position and orientation of real-world points of interest. Typically that involves computer vision to determine, for example, the location orientation of markers, or kind of markerless technology, trained image targets, or if there's a depth sensor available, or if there's other SLAM technology in the device, spatial anchors that come from a room scan, so the actual 3D position in an indoor environment. There are sensors used. Sensors are devices that detect or measure physical characteristics and communicate the data generated digitally. For example, a camera or a depth camera or a gyroscope, if you're thinking IMU, inertia measurement unit. There are different sensor systems used and popular for tracking. The most popular these days is certainly the optical tracking, because it's widespread. Cameras are everywhere, either fixed installed or on mobile devices already. There is also acoustical tracking and electromagnetic tracking, or mechanical tracking, where the position of cogwheels and arms determines the position of something popular in museum installations, for example. There are then depth cameras for tracking in the more advanced devices. GPS, of course, the classic amongst the augmented reality Wikitude-like applications, compass, gyroscopes, and one way or the other, typically these different tracking systems rely on sensor fusion anyways, combining different sensor subsystems to increase the stability and accuracy of the tracking. We call markers and world anchors detectables. That's the super term for those. Detectables link the physical real-world features with the data on how they can be automatically detected, hence detectables. And that informs the tracking system and the sensors of the tracking subsystem referenced. So for the visual sense, that's markers, image targets, world anchors, and the like, but that can be other data types as well, if we're thinking of different tracking subsystems. Hardware is important. We have already looked at the delivery systems, and if we break that further down, there are different choices you can make with regards to optics and subcomponents. Lenses, for example, and not only the type of projection solution that you want to use, but also the cameras that are built in. They can vary a lot, and things are moving with speed. The way that cameras today and depth cameras today are manufactured, that is going to change over the next coming years with new technologies emerging. There are chips available for certain hardware acceleration of computationally complex processes. The HoloLens, for example, is very well known for making good use of hardware to accelerate some of the computationally complex processes. With regards to other delivery systems, speakers matter, and what type of surround sound, for example, you can augment. Haptic actuators matter. For example, if you want to stimulate muscles with EMS, electromuscular stimulation, then you have to build in pads into some garment, or if you want to contract something, you have to have motors in a glove, and so on and so on. Yeah, there may be additional sensors that you might want to use or build into your application, into the hardware of the application, to detect context or to sense user interaction in a specific way. Yeah. Same on the software side. On the software side and the production tool side, there are also different classes of tools available, different classes of SDKs available for object tracking. We've mentioned that repeatedly, but also for object recognition and other cognitive services. There are interaction libraries that automate some of the UI for you, some of the spatial UI. Special effect libraries are available. There are tools for digitizing content. If you need to create a digital twin of something, for example, of course you want the visual appearance as well, so you may have to use photogrammetry tools. Or capture things volumetrically in 4D, so 3D over time, filming a volumetric video. There are animation tools, there's tools for hologram sharing, so things become multi-user, and so on and so on. Yeah, that's, I think, the most important about the key concepts that we have in AR and the key components, and I'll leave it at this for this very brief introduction.